Hey guys, this is Sig, and I'm back with another Golang tutorial. And today we're going to be looking at some more test containers. If you watched my video from a couple of days ago, you'll remember that we did a test containers video where we spun up a MySQL database inside a test container, further migrate from my integration test, and connected to it using a custom client. And today we're going to do something a little bit similar, but we want to try some generic APIs. So in the video a couple of days ago, we spun up a module, right? We spun up the MySQL module, and it was all out of the box, which is great. We got to play with the database. But what if you had a specific API or something you were building or something you're building against, which people often do, right? Often you're building a service that interacts with an external API. And you maybe want to integrate test or integration test calling that API without necessarily calling the real API. So just as an example, I prepared a little example demo today. So I had a look for some free to use APIs around the internet for this video, and I found this, in my view, a little bit ridiculous API, but it's called agify.io. It's just one that I found, and basically what it does is you can give it a name and it will estimate the age. I don't know if it uses AI or some kind of model, but if I give it Sig, it says Sig is 69 years old. Which is complete magic because that is my actual age in real life. So well done, agify.io. And then if I give it my full name, 67. Okay, so I go down a little bit in age. That's good. I don't really know how it... Okay, Camia is 41. Khaleesi, let's have a look. Khaleesi is also 41. Okay. I don't really know how this works, but it does really matter. But what they do have is they have a free-to-use API. So if we go to the API docs, we can have a look, and it says you can estimate the age of a single name by hitting this URL here. So just aka.agify.io and then a name parameter. And we can get and try that, and it comes back, and we get a JSON response. So this is an API that we could interact with. We could build a client that interacts with it. But it says down here, the API is free to use for up to 100 requests a day. If you need to do more, you need to obtain an API key. It's very nice of them to give us 100 requests a day. But let's say we're running a bunch of tests or we're using it quite a lot. We might use that 100 requests quite quickly, especially during development when we're trying to build against this API. So what if we wanted to mock this API, but still have a proper web server running the API, but we want to mock it inside a test container and have our test run against that instead of against the real thing. And then when the time comes to switch to the real thing, if we've mocked it well or we mocked it correctly, we can assume that that transition is going to be a lot smoother. So let's have a go at that. So I'm going to bring up new of them here. And I will say, if you haven't watched the video from a couple of days ago, you don't strictly have to watch it before we go into this video, but it might make some things around the test containers test a bit easier. I'm going to move a little bit quickly in this video because we've got some things to cover. But essentially what I've done for starters is I've created an HTTP client. So for this Agify API, I created a client. And let's just walk through it. Right? It's very simple, but let's just walk through it to get you up to speed. So basically what it does is we have another constructor, which is a palamel I use in all my videos. And we basically call new client, and we give it a base URL, right? And the base URL would be the address that the request is going to go to. And if the base URL is valid, we don't return an error. Instead, we actually create a new instance of HTTP client. Now, Golang is a great language that has a built-in HTTP library that you can use for simple things like spinning up HTTP clients and HTTP servers, which we're going to do as well in this video. So we'll start by creating an HTTP client, and then we just return a pointer to this client. Great. And then our client has one membership function, or one method, and it's called getAge. And it takes a name parameter, and it returns an age response or pointer to an age response. It could succeeds or an error. And as you might imagine, all it does is it fires off an HTTP request to an API, so the base URL, and then with a query parameter name equals whatever you put into name, right? And then it tries to read the body that came back in the response. And if it's a valid body, it will try to JSON unmarshal it, into an age response. And if we look at age response, I just defined it up here. It basically is just the equivalent of the JSON struct that we saw in that agify.io documentation. So this is our simple client. This is what we built. And now we want to test it out. So maybe the first thing you might want to do is just test it out manually. So I've done that here. I've written this testclient.go really simple command line utility. All it does is it sets the base URL to be actual Agify API. Great. And then it calls getAge with sig. And let's see if this works. If I query this, let's just see if we can run this. Let's go run and then test client. There we go. And it fired off under the hood, right? And we hit the API and we got back the age 69 again, which is ridiculous, but there we go. So this is great. And this kind of shows that our thing works, but it's very environmental, right? We have to literally run it ourselves. It runs against the real API, which is not necessarily good. So we would run our requests pretty quickly. We were running a bunch of tests. And as our complexity grows, we don't really want to be testing these things manually. So what can we do? The one thing I like to do is I like to mock the thing that I'm testing with a real API. So let's go in here and I prepared a scaffold file here where we can implement a really simple Golang server. So this Golang server, all it's going to do is going to mimic that API endpoint that we just hit and return some bogus data, but that's in the right format. So the way we do that, again, with Golang, it's great because we don't have to pull in any external dependencies. We can just use the net HTTP library, all good. And all we need to do is we need to implement a function getRoot, which is the only mProm we're going to implement, and then we're going to run this server. So let's go ahead and do that. We can do that together in this video. So first of all, if you remember from the API, we had a query parameter called name. So we're going to say, try to get a query parameter called name, right? And then what we can also do is we can cheat a little bit and actually pull in our age response from in here. That'll just make it a bit easier to marshal our JSON. We might as well reuse what we have, right? So we're going to say this getRoot thing is going to return a JSON age response. And the way we do that is we actually create the response. So we'll say age response equals an instantiation of age response. And then if you remember, age response had a couple of fields. The first one was a count. So for now, we can just say the count is 1,000, for example. You might want to change that a little bit to make it more dynamic. But let's see. And then we can say the age is, let's say I've gotten a bit younger. It's 62 now. Great. So now all we need to do is we need to JSON.marshal this struct, right? So we've got age response. And if that fails, we'll return an error code. We don't expect this to fail, like this is our test server, so we're pretty much in control here. But if it does, we'll return an error code. And if it doesn't, we'll actually send the JSON itself. So with this in place, we've got our endpoint good to go now. It takes a query name parameter and it returns a JSON struct of the correct format. So all we need to do now is spin up an actual HTTP server to handle it. So we'll say if something hits the root address of this HTTP server, then you call the getRoot function. So we handle our logic there. And then finally, we just need to spin up the server. Those HTTP listen and serve. And then we'll say, we'll just run on port 80, which is the default port. We won't pass it any middleware handler or anything like that. And finally, we'll just handle the error if there's an error. Let's take a look. So fnt, so print line, error. And if something goes wrong, they'll just exit out and throw a bit of a fit. So this is our mock API test server. This is a Golang HTTP server that mocks the Agify API that we just looked at. Great. So now what can we do with this? We could obviously run this manually again, and then we could point our manual test client, this one, at localhost 80 instead of Agify, and we could watch it all work. Great. That would be good. But again, that's way too manual. We want to streamline some of this. We want to automate some of this testing. So what we can do instead is we can actually spin up a test container that will run our web server for us. And because we're running in a test container, we have the power of Docker in our hands as well. So let's have a look at what that might look like. So the easiest way to do this is actually to specify a Docker file for our test server. Let's go ahead and build that. So we're going to go in here and we're going to create a Docker file inside our test server directory. There it is. And this Docker file is a standard Docker file, which means that we have all the power of the Docker Hub at our fingertips. So what does that mean? Well, the Docker Hub is basically all the official images that you can pull down. And one of them is golang, which is what we're going to use today. But there's loads, right? You could pull in whatever you need. You could use different languages. You could do loads of things inside this container, all sandbox and containerized. You know, the power of virtualization is at your fingertips. But for simplicity, we're just going to pull down golang, since we've got a golang server here. And this will basically pull down a Linux image that has the Go compiler ready to go. Now, the next thing we can do is we can copy over our source file or our source. So we'll copy this into our Docker container, and then we can cd into our test server like so. And then just to make sure we've got our files, we can run ls. And finally, we can just go run our server.go. So this is all we need to run our test server inside a test container or inside a Docker container. This will basically, it will create a Docker Linux image. It will copy over the files that we need. Actually, it will copy more than we need. We could just copy the test directory, but we just copy the whole thing for now. And then it will just go run server.go, which is listed on port 80 inside this container. And with that, we're almost ready to go. The final thing we need now is we need to do a little bit of plumbing around the Testcontainers test to actually spin up this Docker container, because we could just spin this up and then run our tests against it manually again, but we want to automate it with Testcontainers. So the final thing I've prepared here is, if you watched the video last week, a similar skeleton, Ginkgo Enko Mega Test suite for us to use. And in here, we're actually going to do some behavior-driven testing. So we're going to say, when fetching ages from a mock integration API, which is the server that we just wrote, it should successfully get the age of SIG from the API server. Great. And so what we need to do now is we need to create our test container. So end of the year, a couple of days ago, we used the from tag test containers method, which is a method that allows you to specify a Docker tag, and it will basically pull things in. But this is a little bit different because we're actually going to use our own Docker file. So when you do that is you create a container request, and then you say from Docker file. So from Docker file is a function, and you can see it already gives me a struct that it wants. It wants a from Docker file struct that has some parameters. Now, what are the parameters? The first thing is the Docker file. So the Docker file is what we just created. So we basically point it at the Docker file we just created, which lives inside test server. Test integration test server Docker file, right? And then it also wants a build context. So this is basically the root of the path to the file, or to the directory that will be the build context that the Docker image is built against. And it's relative to the position of the Docker file. So if we say, you can see that if we say // it's relative to the Docker file position. So we go up 2 directories so that we're back in the root, because we want to copy over the root, right? So that's the context of this container. And then to make our life easier, we're actually going to set print build log to true, which will print the Docker build log. And then you can also do keep image, which is an if you want to keep the image around so that it doesn't have to rebuild it all the time. But let's just leave it like this for now. And then we'll give it a few more parameters. We'll expose some ports. So do you remember our test server actually runs on port 80? So let's go ahead and expose port 80 on this container. And then finally, we need some kind of wait strategy, basically a way for the test container to know that our container is ready to go. And since we're running a web server, we can literally just say, just wait for a web server to listen on the root. And this should be for the HTTP uppercase. There we go. So this is our container request. This is the thing we want to build. And now because we're using our own Docker image, instead of run container, which is what we used when we did the test image last week, we're actually going to use a function called generic container. So generic container means basically a generic container that we're defining ourselves. So what it takes is a context again, and then it takes our container request, generic container request, with the container request set to rec, which is the request that we just created. And then the other thing is we can say that started is true, because our container request up here is already going to start the container, so we don't have to manually start it again. So let's have a look what we've got so far. So now we can make sure that no error occurred. So expect no error to have occurred. Great. And then just like last week, we can set vcontainer equal to C to keep a pointer to it around. Now, the only problem we have so far with this code is that our server is going to run on port 80 inside this container, but the mapping port that our code needs to use to speak to this Docker container is not going to be port 80, right? It's going to be something dynamic that the test container spins up. So similar to how we got the connection string in the previous video, there is a utility function we can use, which is basically called map port. And map port takes the context that the container runs on and then a string identifying the port that we're interested in. And we can say, I'm going to just copy this and say that no error should occur when calling this. And then finally, we can set the mapped port parameter equal to port.port, which will give an integer version of the port. Right. So now with this in hand, we should have everything that we need to make our to make our container run ahead of our test. So let's just implement our test because we already have the internal HTTP client that we want to use. So let's go in here and we'll say it should successfully get the HF state from the API server. So let's hit the API server with SIG. But first, we'll print out the map port just to make sure that everything's working correctly. And then we'll set a base URL. So remember, before it was the AGFI real API, but now we actually want to hit our own local Docker image running server. So we're going to hit it with localhost : and then a port. Then we're going to instantiate our client. So we'll pull in our HTTP client like so, and we'll call new client and we'll pass a base URL. So our new client's going to be pointing at the local host, and we'll just make sure there's no error. And then if there is no error, we'll try to get the age. We'll call get age of SIG, right? And then again, make sure there's no error. I'll like this in a second. And then finally, we can assert that the age is correct. So we can say you want the age to equal 62. And I think that was the age that I gave myself. So now we've written a bunch of code, but we've actually really implemented something that I think is quite interesting. So we've got a test server that's mocking the real API that we want to build against. We've got our internal HTTP client, which is the thing we wanted to build. This is the business logic that we're testing. We're trying to build this client with an API, something that uses an API. And we've got an integration test that actually spins up the whole thing in a Docker container and tears it down for us as well. So let's see if we've made any mistakes while doing all this. But if we haven't, we should be able to just run go testing here. And there he goes. It's building the Docker container now. We'll look at this output in a second. It's building away. And it says the container is ready. And here's our test firing off. And lo and behold, a body came back, count of 1,000, namesake, age 62. And our test passed because we asserted that SIG's age was 62. So with these kind of simple steps, it didn't take us very long. With these simple steps, we've actually managed to set up a test environment that we can use to quite easily change some Go code here to make our server more sophisticated if we want to test more things. And then build our own business logic against those features. So we can go to the AGFI API, right? And we can look at some of their other stuff, some of their other functions. And they've got genderize. We could implement a gender. See, SIG, what does it think? Male. That's ironic. We could implement a genderize call as well, and we could implement a really simple version of genderize in our test server, and easily write some unit tests against it that actually exercise real HTTP. Because that's one of the big things here is we could have mocked this in a unit test, right? We could have written a unit test for HTTP client, which basically just runs a unit test and mocks some output and saying, oh yeah, this is what I got back. Here's some JSON I got back. Great. But what if it's a little bit more sophisticated than that? What if it's like a streaming API, or it serves files, or something that has to do with the real HTTP request? We are sending real HTTP requests, and we are actually, communicating with the web server that's running on a different machine, just like we would when hitting the real thing. And yeah, there's a bit of work involved in mimicking the API, but it turns out to actually be really, really beneficial to do that in a lot of scenarios. And you kind of have to make the decision, the trade-off between, do I spend a little bit of time setting up a simple server like this that I can just hit easily and I can manipulate easily? Or is it not gonna be worth the hassle? Basically, that's something you have to figure out. But I wanted to show you this concept, and I hope that you've learned something and you can use this when writing your own APIs. So thank you for watching, and I'll see you in the next one.